Hello and welcome to Lesson 3. This is going to be a lesson all about measurement in chemistry. So we're going to be talking about how you convert between one unit and another. We're going to be talking about the metric system. We're going to talk about how you go from the metric system to our basic English system of measurements, things like how do you change inches to centimeters and things like that. And we're also going to be talking about the accuracy of measurements in chemistry. The very first thing we want to talk about is converting units. And this process gets called a lot of different names depending on what book you're reading or who your teacher is. This is typically called conversion factor. It can also be called dimensional analysis. It can also be called the factor label method, but it's all the same idea. Conversion factor is just a way of changing from one unit into another unit. And you're used to doing conversion factors in your head all the time. These are some problems that you solve in everyday life. A good example would be if you are planning to go to the movies and you know that the movie is 90 minutes long and you wanted to know how many hours is that movie. It's a conversion factor problem because you are changing from minutes to hours, and you would probably be able to do that particular problem in your head. You would use a conversion factor to help you change between minutes and hours because you know that there are 60 minutes in 1 hour. That's your way of converting between the units of minutes and hours. So this isn't something that you've never heard of before, but what we're trying to do is figure out, okay, how do we do the math with this? How do we solve this? How can we write it out on our paper so that the calculations will be really easy to do? Because it's not always going to be something as simple as changing from hours to minutes. Those are units that you know and that you're familiar with. But in chemistry, sometimes we work with units that you might not be as familiar with. So you might be working with a very large unit like megagrams that you don't know a whole lot about. So you need to get really good at the process of writing out these conversions on your paper, doing the multiplication and division, and solving to get an answer. Conversion factor is one of these techniques that if you master it, you will use it all semester in chemistry. You'll see that it's useful for all kinds of different problems. If you really are having trouble with the conversion factor method, you need to get with me. We need to make sure that you understand this. I would say that conversion factor is probably one of those topics that if students understand it, they are successful in chemistry. They'll be able to solve problems all semester long. If people don't understand conversion factor and they don't know how to change between units, they're going to continuously struggle. So we do not want you to struggle, so ask questions early and often. The deal with converting units is whenever you measure something, you always need to specify what units your measurement is in. So if you asked a scientist what units his measurements are in, he typically uses the metric system. In the United States, we typically use the English system of measurement. So there's always needing to go back and forth between one unit and another. So this is why this is pretty important. When you have to do the math, though, everything needs to be in the same units. So our goal in these conversion factor problems is how can we change things so that they're all in the same unit. So let's look at some steps. I'm going to give you steps first, and then I'm going to sort of model some problems and show you how are we using these steps. The first step in solving a conversion factor problem and converting from one unit to another unit, that first step is usually write down what info did they give you to start with. My advice is to read the question and see if you can find a number and a unit that is part of the question. The second thing to do is you need to find a conversion factor that allows you to change between units. So remember the example I was just giving about you're going to the movie and the movie is 90 minutes long. How many hours is that? The conversion factor that you would use would typically be, you know that there are 60 minutes equals 1 hour. That's a way to convert between those units. The conversion factor will either be something simple like that you would know off the top of your head, or it might be something that's given to you in the problem. If it's a metric problem, you're going to have to memorize those metric prefixes so that you'll know the conversion factors. So you would need to memorize something like 1 kilogram is equal to 1,000 grams. You need to remember that kilo means 1,000. So you'll have to memorize those metric prefixes to use those as conversion factors. The third thing you're going to do, you're solving this problem. So we've read the question, we found the number and the unit that were part of the question, we know how to convert between those units, we know our conversion factor, and then you're going to want to write this problem out on your sheet of paper in front of you so that your units will cancel. The rule of thumb is whatever unit you started with is going to go on the bottom in the next step of your problem, and I'm going to show you that in just a minute. The last thing that you want to do, step 4, is you want to solve. You want to make sure that you tell us what units your final answer is in, and you want to give the number and the unit as part of your answer. Numbers by themselves are pretty useless in chemistry. So if you tell me the number 4, I'm going to be sitting there going, okay, for what? What do they mean? Do they mean 4 hours? Do they mean 4 minutes? Do they mean 4 light years? I don't know. You have to put a unit with every number. So let's look at a couple examples. We're starting here just to get the idea of how does this process work, how are we solving these problems, how do we write them out. So understand that with conversion factors, you can think of these things like fractions. Okay, remember earlier I said 60 minutes equals 1 hour. That's a conversion factor. 60 minutes equals 1 hour. Another way of saying that would be 1 hour equals 60 minutes. They're both equal. Doesn't matter how I say it, they're both equal quantities. So another way I could write that is like fractions. So I was trying to have a little bit more of a chemistry example. So in this slide, I put 1 inch divided by 2.54 centimeters, or 2.54 centimeters divided by 1 inch. They're equal quantities. I can set this conversion factor up either way. I can put inches in the top of the fraction, or I can put inches in the bottom of the fraction. But I'm still comparing it to centimeters, so either one of these, they're equal comparisons. We're going to write these problems out, and when we do that, usually the unit that you are trying to change it to goes on the top, and the unit you are trying to cancel out goes on the bottom. So I might not have been making sense so far. Let me show you a couple examples, and hopefully this will start to click a little bit. I wanted to use some problems that really didn't have a whole lot to do with chemistry, because I want you to just get this in your head. Okay, how do I solve these problems? How do I write it out? So the example 1 is probably something that you could do in your head without needing to write it out on a piece of paper and do it like a formal chemistry problem. But we just want to show this to you, okay? You have $7.25 in your pocket, and it's all in quarters. You want to know how many quarters do you have. The first thing to do to solve this problem, you would want to read through this problem and find the number and the unit in the question. So I see the number 7.25 and my unit is dollars. So I would go ahead and I would write that first. Then you see that I put a red X there. That X is for multiplication. So what I'm trying to do is I'm trying to show you here that if I write the rest of my conversions like fractions, I can make stuff cancel out. So I started with $7.25. So dollars was my starting unit. I would want to make sure that dollars went on the bottom in the next part of my conversion, because that unit dollars needs to cancel out. You could think of this as being like if I said 7 times 1 over 7 equals 1. Anytime that you have a number in the numerator and the denominator of a fraction, they're going to cancel out. So in my example here, I have dollars on top, I have dollars on bottom. The unit dollars is going to cancel out. The unit that I'm trying to change it to, I want my answer in quarters. So you can see that I've put quarters on the top of my conversion factor. The way that this is going to work is with fractions, you multiply the numbers across the top of the fraction, and you divide by numbers that are on the bottom of the fraction. So to get my answer, it's going to be $7.25 times 4 quarters divided by $1. And I did not get the final answer for that. Let's see. What's that going to be? 29 quarters, I think is the answer that I get. Because 7 times 4 is 28. And then 0.25 times 4 is going to give me 1. Yeah, 29 quarters is your answer to this problem. Let's do another one. Okay, example 2. This is maybe a little bit more of a chemistry problem. We're using some different units here. And part of this question is some basic information. There are 12 inches in a foot. That's a conversion factor. 12 inches equals 1 foot. That's a conversion factor because it's a way to switch between those units. 0.394 inches in a centimeter. Another conversion factor. That might be useful. And 3 feet in a yard. So 3 feet equals 1 yard. Another conversion factor. They're giving me that information because I might need it to solve this problem. Now we come to how, which is a question word. So I finally got into the question part. How many centimeters are in 1 yard? So looking at the question part, I want to pull out the number and the unit that are part of the question. So the number and the unit that I'm going to start with, I am going to start with 1 yard. I want to set this up. I want to set it up like fractions, okay? So looking at the information they gave me, I know a conversion to change between yards and feet. 3 feet in a yard. What I want to do here is I started with the unit yards. I need that unit to cancel, so that's why I'm putting it on the bottom. The unit that I am changing to is feet. So what I've done, I had yards on top and I had yards on bottom in my conversion factor. That unit cancels out. Okay? The question actually wants me to get to centimeters. So I've got to do a little bit more work here. Now let's see. I can change from feet to inches. Do you see that conversion? That was the one they gave me first. 12 inches in a foot. So right now, feet is on top. So feet needs to go on the bottom in my next conversion. Feet on top, feet on bottom. Those units cancel out. And now I have inches on top. 12 inches were in 1 foot. Okay, my last conversion, I have the information how many inches are in a centimeter. So inches is on top right here in my conversion, so inches needs to go on the bottom in the next step. Inches on top, inches on bottom cancels out. They told me that 1 centimeter was 0.394 inches, and now I'm ready to do my math. What I want to do, I want to multiply all the numbers across the top, and I want to hit equals on my calculator, and then I want to divide by any numbers that are on the bottom. So in my calculator, I would plug in 3 times 12, hit equals, and then divide that by the 0.394. Remember, multiply numbers across the top, divide by numbers on the bottom. And that gives me about 91.37 centimeters. I'm not real big on how you round. I don't care as long as you are in the same ballpark with what I'm getting. The thing that I care most about is I want you to understand how this conversion factor thing is working. What you're doing, you're finding the number and the unit that's part of the question. That's always your starting point. You are going to use conversion factors to change between units. And you are going to write these conversion factors like fractions. So what you do, the unit you started with that was on top needs to go on the bottom in the next step. The unit you are changing to is going to go on top. And you are going to keep stringing together conversion factors until you make the units cancel and you are left with the unit that they ask you to find. The question said, how many centimeters? So centimeters is the only thing in my problem that I have not canceled out. It's the only unit that didn't cancel. The other thing to remember, people get real confused. You can only cancel units, not numbers. So it was like when I went from inches to centimeters, notice that I just canceled out the unit, just the inches unit, but I didn't cancel out the number. So I hope that helps. On your Lesson 3 worksheet, you have some more problems to try. We just want to see, can you set up these conversion factor problems right? Okay, and then we're going to move from there and start talking about metric problems and maybe some conversions that are a little more specific to chemistry.